Welcome, Reg audience. We hope you're still there. We're really sorry. We were just about to start and all the power went off and all the computers stopped working and everything. There's absolutely no one here who knows anything about computers at all. So it's like, yeah. So no, we've got it all fixed now, we hope. And the proof of that is that you can see and hear me. So what we're going to do is we're going to broadcast slightly shorter today. Tony has kindly volunteered to take it out of his analysis slides, and we will also take some time out of me making silly jokes. That's probably the best thing, isn't it? Today it's Flash. Flash, storage technology, boom, boom, boom. And because Flash is something that we know that you have some reservations about, that you know is on the horizon, that you also know that you're going to have to find out more about. So we've got some people in the studio who know all about that, and hopefully they'll leave you better off. If you've got any questions, make sure you remember to ask them. If there are some things on the slides that we skip across today because we've got less time, remember you can download the slide deck. And so you can catch up with some things afterwards. You can also get in touch with us afterwards. If there's anything that you look at afterwards and think we didn't cover that, get in touch with us and we'll pass it on to the people who will help you. Now, who are those people going to be? And welcome back to the studio from HP, Phil Hooker. Phil, you came here once before. It was less dramatic last time, wasn't it?
Yeah. Very smooth last time, yes.
Yeah. So, Phil, remind everyone, what do you do at HP?
Morning, everybody. I'm a storage strategist across EMEA, so just planning anything to do with storage at HP going today and going forwards.
So it's a promotion from being a storage tactician, I suppose, isn't it?
Yeah, I suppose, yeah. It's a different job title, let's say.
Yeah. And joined today, a first-timer in the studio, James, hello.
Good morning. I'm from HP. I'm also a storage strategist, working in the same team as Phil. Working across Europe, looking at all things storage, what's now, what's in the future, and generally helping customers on that front.
Do you find that with your customers, do they think about storage strategically?
Some of them do, some of them don't, I think. I think most of them have to. So it's an interesting world in Europe.
OK, now, and also the Dark Lord is with us today, Dr. Stats. Tony, welcome.
Thank you very much, Tim. Good to be back again.
That's I was humming Queen. That was Queen, Flash. That was silly. And you have something in common with Brian May, Queen's guitarist. Don't
do
you?
I?
Yes, you do. What do you have your PhD in?
Well, that was infrared astronomy. It was a long time ago.
Yes, because
way back in the mists of time.
Because he also has a PhD. I think this is in astrophysics, is it not? We ought to, yeah. Maybe somebody knows. And also, there is me. Remember, I'm fielding the questions. I'll put them to the guys today. So please ask away if you've got stuff to do, and don't wait because you have less time to wait than usual. So, Tony, this sort of brings us up to the slightly sad state of affairs we're in at the moment with storage, doesn't it?
The register audience have told us time after time that, yes, there's more data being created, everyone knows that. But for the first time, the cost of storage is actually becoming visible in budgets. Before, it was always part of something else, so there's some slight changes there.
Before, it was wrapped into the cost of the servers.
Yeah, cost of everything else, just hidden cost. But now it's visible on its own. More than that, storage skills, as we know, have always been scarce. People resources are difficult to get hold of more to actually manage all of this extra data that's being created. But more important, for the first time in many organisations, storage performance is becoming visible on its own as well, because all of the other excuses for why things are not running as quickly as we'd hoped have gone away.
By storage skills, what skills do storage people need?
Well, most organisations have IT generalists that look after everything, so storage is just part of their everyday life. It's only the big data centres that have got people who only look after storage. And so looking after storage takes a range of different skills. If you get into it in a great depth, and that's something that's difficult to get hold of. If you're a generalist, you just haven't got the time.
OK, so we'll help with that today. That's one thing we will be helping with. So, now, guys, James, take us through this on these customer challenges. Now, So, yeah, SLAs.
So, well, we're going to lean on slightly from Tony. These things are kind of usual things that we expect to see, increased cost, missed service levels. We've added user experience here because that's something that's kind of coming to the forefront. And when we talk about SLAs, traditionally it was always about uptime and availability and making sure the application was running, when really it should have been about, well, how quickly should I deliver that information to my end users or to my customers, as well as looking at the resiliency side. So now what we're seeing, because of the need for more performance, because there's lots of different applications, whether it's tablet-based or PC-based, getting that information and getting value from that information quickly is becoming far more valuable, and that's where the user experience comes in. If we get that wrong, we have unhappy users, and typically they will either not use an application or it impacts revenue and business growth or business decisions. So the SLA piece now it's about availability, and it's about delivering that information to my end users in a realistic time frame. And the costs are incurred because if we look at traditional storage technologies, monolithic type arrays that haven't really changed over the decades, the answer to that is to put hundreds of disk drives in them. And what we see with hundreds of disk drives is A, the cost of that, B, the running cost of that, the power, the space, the cooling, and the skills. And those skills aren't just provisioning anymore. They're trying to look at what's happening, what's hot, what's not hot. So they spend a lot of time doing that. And ultimately it all boils down to, if you get it wrong, then the user experience is poor, then you have, IT then becomes kind of the blame for everything. We can't do our business, or we can't react quickly enough, or we can't be competitive because our infrastructure isn't fast enough, we can't adapt quickly enough, we can't get the information quickly enough. And that's really the shift that we're seeing, is a much more focus on the user side of it and what it means to get data to and from them.
So we've reached the end of the road, Phil, for that sort of thing of just adding more and more and more disk drives to the same kind of storage.
Yeah, I mean, people still try and do that, but it's just not cost effective anymore, because cost is such a key thing now. You just can't keep doing that. If I had 500 disks and need to go twice as fast, I can't put another 500 in. I haven't got budget, I haven't got the space. I need some way of doing that smarter.
Okay, so that's what Flash is. Well, it's more that it purports to solve, isn't it?
Yes.
Okay, that's it. Yet, Tony, and on this one, on SLAs, you still see storage being marketed as it goes this fast and it's this available. There has to be a translation into something that's meaningful.
Always. It's something we've talked about on many Regcasts before, that you've got to have SLAs that mean something for the end users rather than simply what can you measure. And that's, again, part of that expectation that's changing on the part of users.
Mm-hmm. Is that something that you help your customers with, to do that translation?
Yes, actually, and actually something that I get more involved with these days is not, it's first of all, I need something that goes this fast, but then you very quickly move up into either the database or the application, because before it was like, well, I need this amount of performance and this level of latency. Now I get requests when I go into Europe is, now I need to deliver this query that currently takes me 9 minutes, I need it in 4 minutes. And that's how I'm measuring the success of this project, or the success of this infrastructure, is actually reducing my query times or my application response times, or delivering my batch reports in half the time that I used to. And that's the shift that we're seeing. And customers are actually doing that themselves. We're helping some of them. But a lot of customers are already starting to come to that conclusion. This is the bit I'm worried about, is how quickly I can get stuff out to my user community or my customers. And that shift is already happening, and we help some customers, but a lot of them, certainly the Tier 1 organisations are already in that mode as we speak at the moment.
Right, and so we're going to get to later on, we look at some of the alternatives for deployment, depending on application,
absolutely,
sort of thing, and that's how we actually make sense of this sort of stuff. Now, Phil, this is a slightly depressing slide, isn't it? What's happening with hard disk storage? When you got into storage,
yes,
you weren't expecting this to happen.
Yeah, I mean, despite my youthful looks, I've been around for a while in storage. So, originally, people bought storage based on capacity. It was just storage. How much do you want, and how much did it cost? And there were some features, reliability you wanted, but it was pretty much the amount you bought was based on the capacity you wanted. As times change, you can see by the indication here, processor, memory, all those things have gone substantially faster, and hard disks haven't really gone much faster. In reality, they've gone substantially slower, because the disks are the same speed, but they're now 5 times bigger than they used to be, or 10 times bigger. So your performance per gigabyte has declined dramatically, whereas the CPUs have gone up. So now storage, unfortunately, from a hard disk point of view, is the slow one. So when you start looking at performance bottlenecks, it always comes down to storage these days, if you've got a traditional storage system.
So there becomes this sort of gap here, doesn't it? So when you see this bottleneck, then it ends up that if you're researching why something isn't working optimally, then you're the bad guys.
Typically, and then you start to see all the servers guys, well, our CPUs are running at 10%, they're not doing anything. I bought this very fast CPU that's not doing much. Well, that's because it's waiting on the storage, and the storage is running flat out, so it's running at 100%, and that's all it can do. And then you start buying bigger storage arrays, putting more money on it, and suddenly the budget going to storage becomes disproportionate to try and solve the problem. And that's what...
Yeah, this is what you call the desire gap.
Well, there's certainly a perception gap that people want things to be better, but actually working out where the root cause problem is in any service quality issue is not easy. And so people have gone through all of the simpler steps first, so increase the processing speed, add more memory, all of that stuff works to a degree, but eventually you reach a bottleneck, and at the moment the bottleneck in a lot of applications is turning out to be the storage.
Now, what's driving people's wish to be better?
And again, this is looking at things from the business point of view rather than the IT point of view. As you can see, top bar, the biggest issue is obviously cost. The cost of storage. People have recognised that for the first time. They know they're spending a fortune on it. There are some studies that say that in some data centres, many data centres even, the cost of storage is the biggest single component of the entire budget. So that's something that people want to optimise, bring down, essentially. But then there are these other two big green bars. They're boosting user productivity, making better business decisions, to get back to the sorts of things that Phil and James were talking about earlier. People want to make decisions more quickly. They want to get the right answers from a huge array of data.
Yeah, I suppose making good decisions. We get back to. I hate using the buzzwords on this sort of thing, but we're back on big data and stuff like that, aren't we?
It can be, but it can be as simple as, before you had a database that would typically do one thing, and it would serve the user community. Now you've got other applications that are coming into that database to get that, and it's not necessarily a large volume of data, but you're trying to derive more from it. And that's what's causing the bottlenecks and the storage, and that's where when you're looking at poor user experience or maintaining user experience, they're the types of places where you start to see that contention. It's I had this data set, it did this, but now it's doing 7 different other things, because those 7 other different things allow me to make sure that I don't have too much stock in my warehouse, or I've got just the right amount of something. So it's cash flow, or it's revenue, or it's profit.
Doesn't have to be big. It's more about real time and getting answers now rather than waiting 4 weeks to find out what happened 2 months ago.
You're exactly right. You see, so I'm immediately defaulting to old thinking of it, and you just had some more hard disks under this sort of thing, and you're saying no, it's actually the performance, getting stuff in there and getting it out again.
Yep.
Great. Okay. Look at this, the data lifecycle. Now, your data lifecycle, Tony, has got ultimate disposal. People never throw data away, they just keep it somewhere less important.
Well, that's what people have tried to do in the past. And more that expectation that data will be kept around forever is an expectation. But it's expensive to do if you keep the data where you put it in the first place. And that's the problem, that many organisations have put storage systems in place where data is created, it's put in place and left alone. Which worked in the past. Because of the sorts of issues we're talking about now, that's not likely to be the case. We're generating more and more, can't keep everything on the same storage that it was created on, because the value and the importance of that data changes over time. And that's something that everyone knows, but they don't often get time to think about.
But it becomes a problem moving data around, because you have to work out what to move, where to move it, when to move it, doing these sort of things. It sounds simple enough, but everybody knows it's not as simple as
Which is exactly why most people leave it where it is,
Yeah.
because it's just too expensive and too difficult to do. So, but if you can automate this or get someone to assist you with it, then that's where the real value is.
Automation. This is the secret to this, is it? Yeah.
Yep.
I think automation and classification as well, because if you have a bit of data that's in the same place, that will never get access, then you want to move that. But if, for whatever reason, at the end of every month or every year, there is some process, not big data, but some kind of process that says, I need to look at everything over the last 3 years for trending, then you need automation or automation and monitoring that's aware that you need to, that sometimes it may be required and it may need performance, and other times that it doesn't.
Yeah.
So the classification piece is key, and the automation piece is key as well, because you can't have someone manually, sitting at a keyboard at different times of the month or the year, moving stuff around manually, because it just doesn't work. You can't scale doing that.
They haven't got the time to do it either. There are too many other pressures.
So what's the project here then? If we're talking about, the classification sounds very simple, but I've got a feeling, Tony, that that's several months of work getting that automated.
Well, data classification is anything but simple, depending on the degree of complexity and how sophisticated you want to make that classification. But as we go on to the next slide, you can see that many organisations are not even clear what data they hold in the first place. So actually finding the data, making sure you've got everything that they
Is
need.
that really true? I mean, that's the sort of thing analysts say,
It's the sort of thing analysts say, but it was certainly true when I was an IT manager, and talking to the red readers that are out there when we go around, it's still the same today, because again, it's created, it's moved, maybe copies are kept for testing purposes or development purposes, and then somehow they get moved into live systems and they're not really treated in the same way. So there's a lot of data created out there that we're not quite sure what it is, where it is, how it should be protected, what sort of performance is required from it. So doing data classification is really important, but you can't boil the ocean, so you've got to start somewhere and decide, well, okay, what are the things that we need to look at first? We'll start with that and try and keep classification simple rather than 97 different subcategories.
So if anyone does locate Tony's lost data, mail it to us, register.
Oh, no. I believe that.
Some of the places you work, then it might be quite interesting. When we're looking at this, where there is a sort of like a where do you start on these, putting these principles into. How do you start? Do you start in one area of the business? Do you say all the stuff we've stored in the past? We'll get to that later. We'll start with what we're the data that we're creating now.
You typically start where the expensive stuff is. I mean, if you've got typically it's I've got a system maybe due a refresh, so I'll start looking at that particular environment first because that's where I need to spend my money on it. Well, my new system, I'm less worried about that. It's on something. A couple of years' time where I get concerned about that one. But we often see this. We need to do a storage refresh of a particular area, and the customers often don't know what's on it. They come and say, we need 100 terabytes, and we say, well, what's it for? What do we use it for? Well, we know where this bit, we don't know about this other stuff. And that's often where they get outside helping, come help us and analyse this, work it out where it's going, and give us some assistance with that. But it's typically when you have to do, most people are driven by the need to do a refresh at some point rather than we're making a sensible decision. They kind of do it by accident almost, so we have to do it. Because we can't buy the same one again, it's too expensive, we need to save money. So the way to save money is to actually put the right data in the right place, and that's when you start classifying it.
A good idea is to try and create some policy wrapped around things so that you start off just, classifying one bit, but you've got a procedure wrapped around this so that, when you move on to the next thing, you don't have to reinvent wheels all the time.
What this data's fate is going to be because you've created some kind of policy. Again, not terribly simple, I would imagine.
No, it's difficult, and the problem is you're often reliant on the business unit or the owner of the data, giving you some kind of feedback as to how much of it or what of it is important and what isn't. And most of the time, they probably don't know, or the answer is all of it. Yeah. And that's the difficult part. So whatever you do, if you can apply some policies, and you can agree that with the business, that's great. Or you have to do something that's transparent so they don't see it. And that could be tiering or something else at the back end. So it's different ways of looking at it, really.
And that classification where the end users say all of it is the most important, that's where you need some sort of throttle on their classification themselves, because if you give people a choice of, yes, is this, absolutely super important or, unimportant, we can do whatever you like with it, they're always going to pick the first. So you've got to have something on there that makes them think, well, if I do that, what's the impact on me going to be? And usually that means you charging them more or at least blaming them more. So some form of chargeback or report back.
I think it becomes easier when there's chargeback because people don't want to pay the most expensive cost for all of their data if they can see that they can reduce that. Then that does make it more palatable for them to look at actually doing some kind of classification on what they do have.
Forces people into making difficult decisions on priorities. The chargeback, I mean, a theme that we've had going through Regcast is chargeback is a goal, but it's something that's some way. At the very least, being able to report.
Yes.
Yep.
That's stage one. At least knowing where it is.
And move that on. But what comes out of this, the moral that seems to come out of this is that whatever we say today, even if you're extremely enthusiastic and you think, Phil and James seem like good guys, I'm going to call them up and get some, get some strategy and get on with things. That doesn't mean that you're implementing straight away. The hard work has to be done beforehand.
Yeah, you've got to do some thinking.
Otherwise, you're just going to end up with some pretty expensive stuff.
It's not just about technology. There's process wrapped in this as well.
Now, getting on to Flash specifically. Oh, I have to say, Jamie, you asked a question. Where can you get hold of recordings of this and the other Regcasts? And this might be useful for any of you if you're thinking, I like this, I'd like some more of it. They are all available on demand. You will be able to find them on the Register website. You can either search for them or in the white paper section in the Register. That's where you find the on-demand versions of our Regcasts. Through the years now, we've got quite a body of them sort of built up, and some of them extremely useful, rather like this one. And this one is about to get very, very useful indeed, because we're going to tell you exactly what you should be doing and exactly what you should be thinking about, and to help you make some decisions on this. First of all, though, Tony, the slightly disappointing perceptions Misconceptions of flash from Reg readers.
Yep.
What are they telling you?
With any new technology, people always get an impression of it from things they read in the press, things they read in the register, just conversations with their colleagues, with people from the vendors. And this is stuff that we've found from register readers over the course of the last year, couple of years, when flash and SSDs have been coming out. And top of the list is, flash is expensive. It costs an awful lot. And that may be the case in terms of per gigabyte, but is it in the whole when you're looking at some of the performance issues we've talked about? The other thing is
it is more expensive than the spinny stuff at a very basic level. Yeah.
But again, it's what's your whole solution going to look like, rather than what's the individual cost per gigabyte.
Don't solve the problem yet.
But anyway, beyond that, it's flash is really only useful for read-intensive workloads because essentially at the bottom it's got a very, very short life expectancy. Doesn't last very long. It's not like spinning disks. You need to replace it every 3 weeks.
That's a fair criticism of early flash deployments, isn't
and so that's the perceptions that are out there. And of course these are all partly blockers, unless you've really got the time to investigate things.
They seem like very important blockers to me.
Absolutely.
That's if you've got your disk array and it's been running there and it's been sat in the corner running pretty well in fairly unchanged format for quite a few years.
Yeah, people know where they are with hard disks.
Yes.
And then the last one is that it needs active management to get back to the things we were talking about earlier. Can we really automate anything, or do we have to decide what lives where and move it around just with people skills?
And again, the management has been underinvested, hasn't it? Across the board in IT.
Absolutely. Getting investment in management tools is something that the register audience have told us time after time is difficult unless you actually implement it at the time when new solutions are acquired. But there's also the whole policy wrapped around management. And as the IT technology has changed, the procedures and the way people look after things haven't always kept up because, again, we've just put things in and then tried to work out what's the best practice to look after it. So that's all areas that need to be looked at.
Your red line on this is that you cannot really start thinking intelligently about something like flash without thinking as well about automating the management of it.
I think that automating the management is something, again, that the audience has told us is on their list. They know that they have to do more because did we trust automation tools in the past? Maybe not. Now they're good enough. We know that we can do that. We also know that we haven't got the time to do everything manually. We just cannot do it.
Well, okay. There's legitimate concerns, I think, there. Yes. Okay, James, there's the concerns. Let's start looking at it. Now, first of all, the thing that I have to admit that I haven't followed this very well. I had to admit I didn't really know that all flash wasn't really the same. So I'm learning something here. Tell us about the different types of flash.
Okay, so SLC flash, which is single layer, which is traditionally what we have all been using, both in the all flash and the tiered environment. So SLC is really the most performant level of flash, and it has the highest level of wear as well. So to answer the question, around this stuff wears out. You go back a number of years, yes, it did. But now, it's deployed in so many different devices, it's far more robust than it used to be. And if we just look at, SLC, for example, you can write, the capacity of the disk 50 times daily, 100% of the time, and it won't wear out for 5 years. It's petabytes to a single device. If we look at MLC, which is currently where the market is now, so we're all shipping MLC technology, so multi-cell, so effectively, denser. The cost per gigabyte is lower, but typically when you look at the cost of an MLC drive versus an SLC drive, they're roughly the same price, but you're getting twice as much for your money.
Right.
And that's typically what we see. So, everyone instantly thinks, well, MLC, it must be half the price. Well, actually, really, it's the other way around. You get double the density for the same amount of money, which is really kind of what happened in hard disk drive.
That's what storage has always been like.
That's what we do, right?
That's what IT's like.
Exactly.
Yeah. Price is the same, we just change what you give you.
And it's just, it's the density. And we're seeing now, MLC chips getting even denser as well. So, it's 400 gig drives, there's 800 gig drives. There'll probably be another iteration of that at some point where it'll be slightly denser. But if you look at the wear time of MLC flash, it's 10 times the volume of the drive for 5 years. It's significant. You would have to, have a very horrible application that only ever writes, 100% of the time for 5 years. And actually, even at that point, it's not that the drives or the cells are worn out, but that's the point in which the manufacturer will guarantee the integrity of the cell. And then TLC, which is starting to be spoken a little bit about now. some of the big NAND flash makers are bringing fabrication factories online to make TLC. At the moment, for us, we don't really know, what the wear time is. We don't really know what the price per gigabyte is, but it's there. It's in the background, and like MLC, it'll take a number of 18 to 24 months before we probably start to see that in the data center. Mm-hmm. But as a rule, SLC. The interesting thing actually between SLC and MLC is even though the density increases and the cost per gigabyte goes down, the actual performance of those two drives, depending on what architecture you put them into, are very similar. So by going into MLC, you don't necessarily lose out on performance.
I see what you mean. How widespread is the deployment now?
So in terms of flash, I guess for us, I don't know, what's the percentage? We were looking at some numbers yesterday. A significant amount of arrays are shipped with some kind of, whether it's SLC or MLC flash technology in it.
Mm-hmm. Yeah, and I think we'll probably explain that a little bit more when we talk about the different models and the ways you can deploy it, because some ways of deploying are much more prevalent today than the other ones are.
Mm-hmm. But if you're specifying this, where the market is now with flash is the MLC, basically.
Yes.
Yeah. And but TLC coming along, look out for that one in the future.
Yeah.
And if, like Jamie, you're looking back at this Regcast after a little bit of time, laughing about the amount that we say you could store and that sort of thing.
One thing to say about the low IOPS on the TLC flash is it's comparative.
Yes.
It's lower than MLC and SLC, but a lot higher than hard disk.
How much higher than hard disk?
You're talking orders of magnitude.
Yeah,
several.
It's interesting when you look at these flash drives. I bought a flash drive that can do X thousand IOPS, and then customers don't get X thousand IOPS out of it, and they say, well, I wanted 10,000. It says 10,000 on the spec sheet. I'm only getting 1,000. And then you say, well, your application only needs 1,000, so it's actually too fast for you. So when you look at hard disk drives with our customers, they're nearly all running flat out because they're the bottleneck. When you look at flash drives, they're nearly all underutilised from a performance point of view. So if someone said to me, I can buy a drive that's half the speed, half the price, 90% of customers would be much better off doing that because it's already too fast, so they wouldn't notice a difference. Now, my car does 200 miles an hour or 100 miles an hour. If you only have a drive at 70, it doesn't matter. And that's why people are moving to the lower cost technologies quickly.
I see, and that's interesting. And some of the thought that you can put into specifying exactly, how you structure this and how you deploy it will help you to get the very best out of what you're paying for.
It comes back to understanding your workloads in the first place.
Yes. Now, this is how the industry is working on this one, Phil, isn't it? That you have this spectrum. Not all flash the same.
Yeah, so this is interesting because storage has been around a long time. I've been in it a while, and flash is by far the biggest technology change we've ever had, by a long way. Storage has trucked along very similar from a pure technology point of view for some time. There's new features, there's new software enhancements, new ways of using it, but ultimately from the bits point of view, they've stayed the same. Flash changed it radically. And this is where a lot of the existing players are struggling to a certain extent, because we have an architecture that was designed around spinning drives. And suddenly, you need to put something else in it. And it's like, well, our architecture was designed around having 1,000 of these relatively slow devices, by flash standards, in a system. And now I want to put 5 really fast ones in. And the architecture is just not designed to do those. So they're saying, well, we put them in it, and yes, customers, we've got flash. And for some customers, that's okay, because they don't necessarily need all the high performance. So they're struggling to add that in. So these are the kind of companies on the left, and the existing suppliers that most people will have heard of.
Basically, everyone's watching this has got some product from...
Yes, from one of those on the left-hand side, typically.
Yeah.
So there's a whole load of new startups, and there are lots of them. We've put a few of the more common ones on here. There's a whole load of these new startups, and they've designed their architecture around flash. Mm-hmm. So rather than say, well, most of these guys, in fact, all of them don't support hard disk drives, they're all flash. So all we do is design around flash. So it's designed around this very low latency and this performance characteristics they have. So they've solved the problem from that point of view. So now you go back to the big guys, and they're saying, oh, well, our architecture can't necessarily support this. And pretty much all those guys on the left are trying to change architecture. So they're buying someone. So you've got this issue of all the guys in the bottom left, the large existing players, are now buying the startups for a new architecture. So that those customers are now saying, well, I've now got to change, although maybe with the same company, I've got to go through an architectural change, which is a difficult place to be, because we've bought this product and we've had it for 10 years. In all its different shapes and forms, we're very happy with it. Now it's got the same sticker on it, but it's completely different.
And it's bound to be this time whereas we work out how these two types of architecture can coexist. So I suppose internally these guys have got their teams working on how to, now you've got the new guys on that have been slagging them off for a couple of years. You bought them, now you have to work out, how everyone could be friends. Is that going to end up, we all going to end up in the same place? Are we going to get radically different ideas of how existing hard disk drives and flash can coexist?
So a lot of the small startups are doing things quite differently, and that is being adopted by the larger guys. So what will happen when you go forward, when you look at this, when it all pans out a little bit later on, a lot of those guys in the middle will have gone. They'll have been acquired or just not been successful. So a couple of them will carry on to a certain extent. Most of the bigger guys will have adapted their technology, either redeveloped it in-house over the next few years or bought someone and adapted it. So it will still be a lot of some of the existing players, but radically different technology that they're shipping.
Mm-hmm.
And then when you look forward, so it goes even again, because Flash is what we have today, but you start going forward, and Flash is temporary. What we use as NAND today, SLC, TLC, so on. And if you're looking at this regcast in a few years' time, you'll be going, well, that's so out of date. We're now on memristor or phase change memory, which is the next one along. So we're now on this constant evolution of radical changes rather than it's been alone for 20 years. Now it's like every few years it's going to change.
The architecture of the type of solutions that we'll get onto in the next slide will probably be quite similar amongst most of the vendors. The details will be different, and as always in IT, there will be edge cases, so niche scenarios where something will be so radically different that someone will need a pure solution that's not part of the general mix.
Yeah.
That's the stuff that the bleeding edge companies really get into, because there's some serious business advantage into it. It's risky, it takes money, it takes time, and it takes skill. So those edge cases will be there.
They'll sort of define themselves.
By and large, you'll find a bunch of architectural models on how to use this will come into pretty general practice in the next couple of years.
I look on this diagram, there's no HP logo.
Well, HP are interesting because a lot of these big guys are going to go, we've just said, they're going to go through an architectural change.
Yeah.
Okay, so HP have pretty much done that, because when they acquired 3PAR 3 years ago, they saw this change coming. 3PAR architecture was designed around this, so they did it, and we've gone through 3 years of change to do that. So now most people from an HP point of view are on that technology, so we've kind of jumped ahead of this thing, and that's when our strength is at the moment.
You put yourself in a different position to these guys. I see. That's why you got no logo on it. It just suddenly occurred to me. Where are you? So let's have a look at the deployment models here. As we've been hinting at, the way you put this stuff into your data center makes a big difference into how well you can use it. Different things here, Phil.
Yeah, so a lot of the Reg readers will have heard of some of these, but not necessarily all of them, because it depends on the applications or area of interest that you have. One of these is better suited to you. It also depends on who you're talking to, because some vendors only do one of these, so that's what they're going to be saying is the best thing. So, these are the four most common ways you can deploy Flash. So just starting on the left-hand side, so server Flash. So this is basically Flash in your server. So take your standard server, you just drop in a card of some kind, and that gives you very, very fast storage, directly coupled pretty much into the server. So it's the fastest way of doing it. Typically it's used as a read cache, and it's not particularly fault tolerant because it's in the server. So if the server breaks, you've lost that. So it's a very good use case for certain applications that are bursty and want a lot of read. Then there's the all-flash array. So this is where you bought your flash array, storage array, and it's 100% flash. This is typically where a lot of startups are playing, so they focus in this area. So this gives you exceptionally good performance. They've typically made a lot of changes to get around the endurance problems of flash from the past, the latency design of the old architecture. They're very, very fast design, and clearly they're quite well suited to larger applications of fault tolerance, because you can have clusters now at the server, so 2 servers can talk to the same storage array. So better suited for that environment. So
basically you just go to these guys, the flash guys, and say, do the best flash you can for me for this, and they just...
And typically that's around performance. That's usually the demand for that. It's around, I need performance, and I need it across more than one server. So that's normally where people are pushing.
More relevant to people who are just starting up, who don't have an existing... who don't have a lot of existing storage.
It's more to do with people that have a particular performance requirement, an application it wants for. Where we sell these all-flash arrays, people don't just buy an all-flash array. They've got lots of other stuff as well. They buy the all-flash array for this particular use case.
Special thing.
Yeah. It's the low-latency application where you really need to get the answers as quickly as possible.
Right, got it.
And then we move on to tiered flash array. This is where the bulk of the market is today. So this is where I've got a storage array that has hard drives in it, and it has flash in it. Okay, so now I've got the best of both worlds. I've got performance and I've got my cost savings capacity. And the way to do this properly is to have the array auto-tune. We talked earlier on about moving data around. So this is where you have an application and you put it on the storage array, and the storage array works out where to put data. And it's important that it can do this dynamically, and it can do this at a sub-volume layer. So this is not the whole database is in Flash and someone makes that conscious decision. This is going back to the skills we were talking about earlier on. So there's no one sitting there going, this application, put it on Flash, this application, put it on slow storage. We're talking about put it all on the array, and the array works out that this database is getting a bit busy, but only that table is. So that table's on a certain area of disk. I'll move that table onto Flash. So now that database table that's getting all the queries is on the fast stuff. And then all my other applications, which aren't particularly performance benefit, go on to the hard drive stuff. So this is where you drive up the performance usage of your Flash. So we go back to, if you've got a 400 gig drive, a Flash drive, it's only really worth spending the money on it is if you've got 400 gig of busy data. And if you have this tiering solution, by only putting busy blocks into it, you start to get exceptionally good performance out of it. And that's where it saves money. So a tiered Flash array can actually be cheaper than a traditional storage array, even though you're paying extra for the Flash.
Yes, but it very much depends, though, on the quality of the software that's managing this, doesn't it?
Absolutely. So this is about storage arrays that can do this automatically, because you don't want the management costs. Because if it works out, instead of buying 1,000 disk drives, I bought 20 Flash and 200 disk drives. So let's say they give me the same performance capacity. But if one of them's really complicated to manage, and I spend a fortune having 5 guys moving stuff around, I've negated that performance whatsoever, that cost benefit as well.
Mm-hmm.
But it's an interesting one, though, because some of those operational costs are hard for organisations to quantify.
Yes.
Yeah.
But there's also a lot less risk in this, so you get much more consistent performance as well. Mm-hmm. So if you take the manual elements out, you lower risk. You almost certainly lower costs, operational costs, but recognising that can be tricky sometimes.
Is this a kind of like is this a sort of an intermediate stage where we're at here, the sort of last dying gasps of disks that spin? You know, so we're keeping them around until they're no good anymore, but eventually we'll all be all Flash.
We said that at Tape many years ago, and Tape is still going strong. I mean, hard disk drive...
Much to everybody's delight.
It's still there. But I mean, the hard disk drive here for a very long period of time, because yes, Flash is coming down in cost, but so are hard disk drives. And it's about... There's this happy medium when both are going to be needed for a long, long time, and I think that's where people are pushing it to.
It's horses for courses. You know, some things Flash are really good for, some things hard disks are really good for, and it's making sure you've got the best balance. So there are some vendors that would have you believe that, you know, hard disks are on their way out. You know, they've started the slope to never, never land. They're going to disappear. As Phil said, I suspect that if it's going to happen, it's going to be a long, long time away.
So this management capability that you need here, where is that located? Where are you getting it from?
So typically that's inside the storage array itself. So the storage array looks at, because it understands which bits are busy, so it's looking at all of its blocks of areas inside the array, saying these bits are busy, I'll move them, these bits aren't, I'll move them down. And that's where the intelligence typically lies, inside the tiered Flash array doing it for you.
Mm-hmm. And how customisable should that be?
It needs to be certain amount customizable, because certain applications have different profiles. I mean, if the array does it, say, once a day, it optimises itself, but you've got an application that gets really busy for an hour a day, then if you average it out across a day, it's going to say it's not very busy, so it'll go down to a lowest tier. So you need to be able to define profiles, different profiles within the same infrastructure, so it can react to certain application need. There's typically a bucket where everyone goes in the default one, and then there's a certain applications which are unusual, and then you have to categorise those.
And in the future, you're going to see more and more integration between the arrays management capabilities with, you know, sort of policy engines that sit above them at a more business level. You know, that's something that's still relatively new today, but to get back to the stuff we talked about earlier, getting the processes and the policies right for how data is treated over its lifetime are things that are still essentially evolving. And by that I mean evolving in the true evolutionary sense, that we're trying lots of different things, some of which are really good and some of which are not so good.
Oh yeah, try and get the evolutionary things that work in the short
Finding best practice in any new area is really important, and this is certainly one of them.
Yeah. Have we dealt with all of these?
No, and the last one is FlashCache. So this is basically where you have a normal storage array with a bunch of Flash in front of it, which is actually like a cache or a buffer.
Oh.
So this is quite well suited for applications that are a bit bursty. So an application that sits there quite happily, not doing too much, and suddenly just goes mad for a short period of time. So where something like a tiered solution may not be able to adapt or move stuff in time. So that's when a big chunk of Flash in there can just temporarily cope with a huge influx of data and sort itself out a little bit later on.
Great. Before we finish, and I'll ask you for some specifics on these sort of things, particular applications, because I know some people are asking about it. We do have one sort of question that comes up. Where does HP Fusion I/O, where does that fit into this?
So that is in the server flash cache. So this card goes in the server, gives high performance directly on the server, typically read cache for certain applications that require it. The left-hand side.
Yeah, that's good. And there's someone asking why they would consider HP I/O accelerators over SSD. It's all very confusing. SSD is much cheaper, but what's the risk?
So SSD in the server versus a flash card? Or SSD in an array versus a flash card in a server?
You're going to have to guess. I just read the questions.
So I think with a flash card, which is directly on the PCI bus, it depends what you're using it for, but the CPU and memory will have direct access to it. As Phil said, typically for read, but also for transient data. If it goes pop and the data's in there, it's not too much of an issue for me. But, you're looking at very, very low microsecond latencies. So big improvement to an application if it can handle that. But relatively easy to manage. I plug it in, I load a driver, and away I go. SSD drives, are probably equally as, or probably less expensive to put into my server. But if you look at what people have tried to do, which is to take drives out of servers and put boot devices, onto storage devices and have kind of, a server without any storage in it. It's a bit of a reversal, but it's the management of those disks in that server. Because if I do anything to it, I have to be on that server. If you look at flash cards, most of them, and the I/O accelerator that we have, you can, there are software that allow you to manage them holistically. I can see all of them in all my servers. But again, it comes down to, how many people do you have, what skills do they have, and where do you want them spending their time? Creating RAID groups on servers or doing something more valuable and looking at database performance or something like that.
Yeah. And it's a case where there's no black and white answer. It's going to vary company by company.
It's entirely on
even application by application within the company.
And over time for the same application.
Absolutely.
Yep. People miss as well.
Making a good case for your services here. Now, is there a case, Chris has, is there a case for just doing away with the storage away completely and just putting the flash in the server? What's the case for that?
I think actually the next slide will kind of talk about
Let's go to the next slide, because that would be a more sort of helpful thing. It's like when you start answering questions, you see, it's not
preempting
more, and I want to make sure people get their questions in. Yes. So, the day one design requirements, I'm always very keen on letting the audience go away with something to be able to think about. Yeah. This seems to cover it.
Yeah, so, off the back of that question, but, for me, when we're, seeing customers, typically when we look at an application, when someone is interested in Flash, it's usually something, that thousands of users are using or plugged into, or it's a really critical database. And it's very easy to just get completely sewn into, I'm just looking at latency and IOPS.
Yeah.
And people then, not necessarily forget or ignore, but, you've got to think, okay, performance is key, and it's either IOPS or latency or both. Efficiency is another element. I don't want to buy something, put one application on it, then I can't put anything else on it because it's expensive. But people forget about the resiliency or the availability, because that's important. If I'm taking what is probably a very important application, I need to think outside of the performance element and think, right, if this goes down, what happens? How resilient is my device going to be? So, if you put storage in a server or SSDs in a server, it makes it hard to cluster it and to replicate it and to do all that good stuff.
Yes.
So your risk domain becomes, quite small. If something goes pop in that server, that could cause me an issue. So, hopefully that answers that one. But and then also functionality. If this is a tier 1 application, which, if someone is trying to boost something, they typically are very high profile. How do I protect it? I probably want to do some kind of snapshots, because someone's going to want to do test and development or support analysis, if something's going wrong. I probably want to replicate it, because it's got all my finance data in it. If something happens, I need it somewhere else. And then the main thing that we see people forget is, how do I get it to that solution? Whatever I've architectured, I've looked at performance, I've looked at efficiency, I've understood my resilience and my functionality requirements, and what drops off of it is how do I get my data and application onto it? Can I take downtime? Am I allowed downtime? What's the risk of moving it? How do I mitigate that risk? So data mobility is becoming even more important, because, if I end up in a world where I have, probably a flash device for some things, a tiered device for other things, because the good old disk drive is there for, 80-90% of my data fits really nicely on there. Application profiles change. I want to be able to move. I might have to move stuff around.
And potentially you might even have an archive hanging off the back, because, as we said, people don't want to delete data. Want to keep it forever, but you don't want to keep it on, this expensive stuff. Even spinning disks are expensive if you're keeping stuff for 20, 30, 50 years, even for 10 years.
And if we look, going back to the slide that Phil talked about a couple of slides ago, most of the startups, the kind of the all-flash vendors, they're really playing in the performance and the efficiency space. It's all about IOPS. It's all about low latency. Low latency is what gives you a benefit to an application. Having lots of IOPS means you can consolidate because you don't run out of performance. Right? So there's kind of two different ways of looking at that, and it's key to look at it like that, because just because I have 200,000 IOPS does not necessarily mean my application is going to go faster.
Yes.
It's the latency that will make that difference. And the IOPS means that I can put it on there without ever having to worry or consolidate more to it. But it's not, the IOPS doesn't necessarily mean it's going to go faster unless I have the compute to drive it. But you also have to look at the application. How is it written? Because I've just done a load of testing with a company not so far from this location to do risk modelling. And we took it from 1 HP array, which is tiered, and we put it into a flash array, which wasn't tiered. Nothing went any faster. And it didn't go any faster because of the way the application is written. So, firstly is, you've got to look at all of these things. Performance is key, yes. Efficiency is key because it's expensive. You want to get the most out of it. It's got to, reliability should be key. It might not be key. That's a decision you have to make. The functionality piece, can I do it up here or down there, at the host or the array level? It's a key one. How do I get data on and off of it? But then, outside of that, looking at classification of data, but look at the application.
Are you going to find out some of this just by having a go and seeing what sort of performance you get?
I mean, a lot of the stuff that I've been involved in are around POCs, because you just don't know.
Yeah.
If you, and we're going to talk about it on the next slide, kind of use cases. If you put virtual desktop on it, right, it's going to go nice and quick.
Yeah.
Because virtual desktop is user experience stuff. If it's slow, if the response from the array is slow, users get unhappy, you've got 1,500 of them, it's not a pretty place to be. Flash is an excellent use case because you get very consistent performance all of the time.
But you need to have it protected, because if your flash array goes down for whatever reason, then you've suddenly got 1,500 potential users who are unhappy rather than one who can't start.
Yes. Yeah, so everything...
System.
Yes, with opportunity comes great responsibility on these sorts of things.
The problem is it's human nature. You're trying to solve a problem. It's not fast enough, so all you're focused on is making it faster.
It's the most salient thing.
You've taken it for granted it's been reliable because your legacy box has been working for 5 years. Mm-hmm. It's not quick enough now. And then you're in danger of buying the quickest thing in the world and designing a quick solution which has no resilience or availability, because that's not forefront of your mind. And then you suddenly think, I've done it, I've solved that problem. I've generated 2 other problems I wasn't aware of.
Do you end up saying to people, "Oh, you're a sort of a type A business. You've got sort of these type of applications. Therefore, we'll do it this way"? Or are there as many different ways of doing it?
There's many different ways. The important thing is make sure the customers always think of those 5 things. They can discount them. They can say resilience. Okay, thought about it. Does not apply. That's fine. But you must at least come across them and think about them. And that's the problem. People accidentally miss out. They forget about data mobility. I've got the solution. It's really, now how do I get onto it? I didn't budget for all that work and people to do it. You've got to think about those 3 things, categorise them yourself and decide what matters for me.
Is it efficient to come to a different conclusion on this, application by application?
If you've got management tools that can look after it, and so systems that can manage that way, yes.
Have I?
Some will work that way.
Uh-huh.
Yeah, and many customers, the larger customers, will have various different methods of doing this. Some applications are performance, reliability, don't care. Other ones are, I don't care about performance, I care about reliability, and have a selection of these.
It's a bit like creating these service pools that we've talked about on many other Edgecasts. You might not have one single private cloud that does everything. You might have silos that are different types of characteristics within them that will run multiple applications, but they've got the same basic set of needs.
Mm-hmm. Okay, we're going to have to wrap up because we're almost out of time. But I'm going to give you a final question. Who wants to take this one on from Ian? What about putting the solid state device in the SAN using the storage adapter? Then you provide the performance and share the flash.
So putting flash within a SAN.
In a SAN.
Within a SAN, within the networking part or within the storage part?
Well, it doesn't say.
Yeah. Well, so there's different companies doing different things.
Yeah.
You put flash into an array, provided you have the right tools to tier it.
Yeah.
You can make very good use of it. When we look at tiering, everyone thinks, it's about moving data around. Well, that's kind of what happens. Actually, it's about putting IOs in the right place. Because if my IOPS are in the right place, I can fill each tier of storage. And that's what I want to show my boss, is my utilization is really high. So that when I'm buying storage, I'm buying it for capacity, not necessarily buying it for IOPS, which is what happened traditionally. So you've got that element of it. But then there are devices that you can plug into the fabric that then sit between an application and the array, and they intelligently go, okay, he's asking for this data all of the time.
Yes.
Why don't I move that here so that I don't have to bother the array for it? Which is kind of a little bit like server cache. There are, caching tools that do that, and it's a bit like storage cache. So, you can put it wherever you like. There's no right and wrong way to do it, and there's lots of different ways. And I guess it comes down to the screen we had before. Is just make sure you list all of your requirements and don't forget about any of the little. And
have a management tool that can help you actually look after this stuff over a long period of time.
Going to say as we wrap up, the key to this seems to be ask lots of questions, doesn't it? Because the answers turn out to be surprisingly
there's
varied.
Still not a lot of experience of actually doing this stuff on a big scale. So therefore, ask the questions. Find the time to ask the questions, and we know that finding time is really tricky for the audience.
Okay, and sort of finding time for us has turned out to be fairly tricky because we've run out of it. See what I did there. But thank you very much, guys. That was great. I'm sorry we didn't have much time, but we got through a lot of stuff, didn't we? And if there are a couple of questions afterwards, or if anyone wants to ask something, because this is a more complicated subject than quite a few actually we deal with, please do ask them. Let us know what you thought of this. Remember, you can download. Remember as well, if you've been watching this live and you'd like to go over it again, it will be available on demand. So thank you very much to Phil and James.
Thank you.
Thank you for coming to the studio. Always thank you to you, Tony.
My pleasure.
That's great. Lovely tie again. Snoopy. And I've been Tim Phillips. Thank you very much for watching. Sorry we started late. We hope you got what you wanted. From the Register, goodbye.